So there's this really harsh mathematical reality in AI right now. I mean, it's something we've been seeing in the notes for this deep dive.
Oh, absolutely. It's the 10-to-5 ratio, right?
Yeah, exactly. A developer who has read like 10 research papers and built 5 messy, just totally broken projects, they will absolutely out-engineer someone who has read 100 papers but built nothing.
Every single time.
Yep.
That ratio, it really separates the observers from the actual practitioners.
Mhm.
We're looking at a landscape moving so fast that passive consumption is essentially a trap.
Right, and welcome to the deep dive, by the way, because you are listening to this because you build things, you understand systems architecture, you know how to debug, you ship software.
Yeah, you're in the trenches.
Exactly. But staring at the absolute tidal wave of AI advancements dropping on GitHub and Arxiv, like every single morning, the question is how to direct your engineering energy without completely drowning in the noise.
It is exhausting just trying to keep up.
It really is. So the mission for this deep dive is to extract a concrete, highly actionable AI roadmap from our source materials today. We want to tailor it specifically for you.
No hype, just the actual mechanics of leveling up.
Right. We're mapping out the ideal skill profile, dissecting the friction of building versus reading, and detailing how to construct a portfolio that proves your competence, plus locking in those daily rituals to keep you sane.
Because surviving this transition, I mean, it means moving from reactive anxiety to highly structured learning. Taking back control requires a blueprint.
Okay, let's unpack this. The most resilient engineers are adopting what the source would call the T-shaped skill profile, right?
Yeah, the T-shape is foundational. So the horizontal bar of that T's represents a broad, generalized understanding across the entire AI ecosystem.
Like knowing the vocabulary.
Exactly. You need to know what URGE is, retrieval augmented generation, where you essentially give an LLM a specific external database to read from.
So it actually grounds its answers in your data instead of, just hallucinating wildly.
Right, exactly. And you need to understand the difference between training a model from scratch, fine-tuning an existing one, or just running inference.
And the data infrastructure too, I'd imagine.
Oh, 100%. You should know when a project requires a standard relational database versus when you actually need to implement a vector database for high-dimensional embeddings.
So that horizontal bar just means you're conversationally fluent across the whole pipeline?
Yes, but the vertical bar, the T, that is where your actual value lies. That's your deep, uncompromising, specialized expertise in just one specific area.
Got it. So picking a vertical drop, let's say my vertical is latency optimization for deployment. Like, I'm the person who figures out how to serve a massive language model to thousands of users without timing out.
That's a great example. Or maybe your vertical is purely data curation. You build the pipelines that sanitize enterprise data so it's actually usable.
But, here's the friction I hear from a lot of developers. Is it a trap for software engineers to try and be an expert in everything AI right now? Because the industry seems to demand these full-stack AI unicorns.
What's fascinating here is that attempting to master everything in AI right now doesn't make you an expert. It makes you incredibly shallow.
Oh, wow. Shallow how?
Well, the field actively punishes superficial knowledge, The surface area of artificial intelligence is expanding exponentially.
Yeah.
If you try to chase every single discipline, you spread your cognitive bandwidth so thin that you just can't solve genuinely complex problems.
You become a tourist in every framework, but a resident of none.
That is exactly the problem.
Yeah.
AI isn't the deterministic, highly predictable gears of a traditional software clock. It's more like a highly pressurized thermodynamic system.
That is a great way to put it.
Right. And you, the engineer, you aren't just steering. You are building the pipes, the release valves, the guardrails to harness that probabilistic pressure without, blowing up your production environment.
Which you can't do if you only have a surface level understanding.
Exactly. Picking one deep vertical makes you indispensable. But you still rely on that broad horizontal bar because software engineering is inherently a team sport.
Yeah, like if I'm the deep expert in deploying open source models efficiently on edge devices, I still need the horizontal knowledge to talk to the data scientists.
Right, the ones shaping the training data, or the front-end developers building the UI. Your horizontal bar is your communication API with the rest of the team.
Makes total sense. It lets you translate the constraints of your vertical into language everyone else gets. Like if deployment latency is bottlenecked by model size, your horizontal knowledge lets you suggest a different quantization method to the training team.
Precisely. You speak their language, even if you don't write their code.
So let's transition into how you actually acquire that deep vertical expertise. Say you pick your specialty, like building highly scalable RGA applications. I know a lot of devs who immediately just start bookmarking white papers.
Oh yeah, reading documentation, watching architecture breakdowns on YouTube, it's a classic trap.
Right. But the source material gives us that hard rule we mentioned at the top, the hands-on imperative.
The rule is absolute. Building projects is non-negotiable. Execution is where the real learning happens. Because, honestly, theory in AI is sterile.
It's like tutorial hell, you know? Many software engineers know that trap well. Reading 100 papers without coding is like reading 100 books on swimming and then just jumping into the deep end. But aren't AI papers essential for understanding the underlying math?
Yes, the math is essential and reading is part of it. But I have to pivot to the reality of the hands-on imperative here. Translating that theory into a working model is where the friction is. And that friction is what builds actual competence.
But wait, how do you expect a solo developer to embrace this hands-on imperative when training a foundational model costs millions of dollars? We don't all have H100 server farms in our closets.
That right there, that's the exact trap that keeps engineers paralyzed. They think they need to train a massive model from scratch. You don't.
So what does hands-on actually mean for a solo dev?
It means taking a quantized open source model like Llama 3, compressed down to 4-bit precision, running it locally on your M-series Mac and trying to fine-tune it.
That's on consumer hardware.
Exactly.
Mhm.
Using low-rank adaptation on just, say, 500 rows of custom JSON data.
And that is where the messiness begins, I'm guessing.
Oh, the messiness is the entire point.
Yeah.
When you read a paper, the equations balance perfectly. The methodology assumes perfectly sanitized data.
Right. Real data is never perfect.
Never. So when you pull that model onto your local machine and try to run a fine-tuning script, suddenly you are slammed with a CD out-of-memory error.
Ah, the dreaded O error. So you're saying that error isn't a roadblock. Fixing it actually forces you to understand how the model allocates attention, right? The friction is the curriculum.
That's beautifully said. You are forced to look under the hood. You have to figure out why your tensor dimensions don't match.
Or why a batch size of 8 crashes the GPU, but a batch size of 4 works fine.
Exactly. You realize your custom data set has corrupted rows, which breaks the tokenization process. You face dependency conflicts. That exact moment where the pristine theory hits the highly volatile reality of engineering, that is where actual competence is forged.
So the developer who built 5 messy projects had to fight through that specific hardware and software friction 5 separate times. They had to actually debug the latent space.
While the developer who read 100 papers has never fought at all. They just memorize the map without ever walking the territory.
Okay, so let's scale this up. You're sitting at your desk, you're embracing the friction, building projects. How do you package this work to prove your T-shaped expertise? Because a Python script running in a local Jupyter notebook isn't going to convince a senior engineering team.
No, it won't. A strong AI portfolio needs to do heavy lifting to separate you from the noise. There are thousands of basic wrapper apps out there.
So what does a standout portfolio actually look like?
The roadmap outlines 3 specific requirements. It must solve a tangible problem, it must demonstrate the full project lifecycle, and it must include a rigorous, honest evaluation of the model's limitations.
Okay, let's dig into that full lifecycle requirement first, because in traditional web dev, a portfolio project might just be a React front end with a Firebase backend. What does the full lifecycle look like for an AI project?
It means proving you can handle the grueling pipeline from unstructured reality to a deployed endpoint. You show how you scraped or ingested raw, messy data.
Right, not just downloading a clean CSV from Kaggle.
Exactly. You document how you chunked that text, generated embeddings, and stored them in a vector database. You show the fine-tuning or prompt engineering phase. And crucially, you show deployment into a production-like environment.
So like containerizing it with Docker, setting up load balancing.
Yes, and telemetry. You set up monitoring for model drift.
Model drift.
Yeah, that's when the real-world data your model starts seeing in production shifts away from the data it was trained on. Its accuracy degrades over time.
Oh, wow. So showing you understand how to monitor for drift proves you aren't just playing in a sandbox.
Exactly. It proves you understand the rigorous, long-term demands of enterprise engineering.
Okay, here's where it gets really interesting. The third requirement, an honest evaluation of the model's limitations. Usually, devs want to hide the bugs, you know? You want your side project to look flawless.
Right. You sweep the edge cases under the rug.
Yeah. If an input crashes the app, you silently hope the recruiter never clicks that button.
Wait, so we should actively highlight where our AI model fails or hallucinates.
If we connect this to the bigger picture, AI models are inherently probabilistic. They aren't deterministic state machines like traditional software. They will always have boundaries, edge cases, and failure modes.
So hiding them just shows you don't understand the tech.
Precisely. When you openly document the limitations, you send a massive signal of engineering maturity to a prospective team. But how do you actually document that without just vaguely saying, hey, sometimes it makes things up?
You build an evaluation framework and put it front and center. You don't just admit it hallucinates. You show the exact script you wrote to catch those hallucinations.
Oh, that's smart, like using a secondary model to check it.
Yes, an LLM is a judge. You systematically score the outputs of your primary model across 100 test cases, or you show the guardrail architecture you implemented that intercepts the output, checks it against a schema, and blocks it if it tries to trigger a fake API call.
You are telling the team, I understand exactly where the bridge I built will collapse, and here are the stress test reports to prove it.
A novice thinks their model is an oracle. A master knows exactly where the illusion breaks.
That's a powerful shift in mindset. So you're deep in the code, building full lifecycle projects, actively measuring hallucinations. But we have to talk about the sheer exhaustion of maintaining this pace.
The burnout is real.
It is. The AI field moves at lightning speed. You log onto social media, and there are literally dozens of new frameworks and game-changing papers dropping daily. How do you survive the fire hose without burning out?
Burnout is the silent killer of this transition. Trying to drink from the fire hose daily leaves you waterlogged and paralyzed. Staying current requires sustainable, heavily defended rituals.
No, binge learning, basically.
Binge learning is a catastrophic strategy.
So the source materials outline a very specific formula for this. Read 1 to 2 papers per week and deeply learn one new tool per month. So what does this all mean for the listener's daily schedule?
This raises an important question about pacing. That specific bounded ritual protects your mental bandwidth. It's a strict survival mechanism.
Well, let me press you on that. 1 tool a month. 1 to 2 papers a week. In a field that changes every Tuesday, that sounds dangerously slow. Aren't you risking obsolescence by artificially limiting your intake?
Well, ask yourself, are you trying to know the syntax of a new tool the moment it drops? Or are you trying to build compounding, durable engineering intuition?
That's fair. If you switch frameworks every time something trends on Hacker News, you spend all your time learning arbitrary syntax.
You spend zero time understanding the underlying mechanics. You're just memorizing wrapper functions instead of understanding the matrix multiplication.
Right.
1 month gives you the required space to actually integrate a tool. It takes weeks to hit the edges of a framework, to find out where its documentation lines to you, to see how it handles memory spikes.
That deep exploration is what gives you consistent growth. You build structural knowledge that transfers to the next tool.
Exactly. Curation over consumption. And regarding the reading ritual, when you only have to read 1 paper a week, you don't just skim the abstract.
You actually read the whole thing.
You look at the architecture diagrams, you scrutinize the loss curves, you read the ablation studies where researchers remove pieces of their model to prove which parts do the heavy lifting.
You might even spend the weekend trying to code a simplified version of their attention mechanism from scratch.
Yes, it is the ultimate defense against hype. By strictly limiting your intake, you give yourself permission to ignore the noise. You put blinders on so you can execute your own T-shaped roadmap.
I love that. So let's pull all of this together and look at the end game. You survive the grind. You have a T-shaped profile. You're embracing the friction of local execution. Your portfolio proves you can ship, and your rituals are keeping you sane.
That brings us to a philosophical question, really. What kind of impact do you actually want to have with these tools?
Because AI is an amplifier of human capability,
Yeah.
right? It doesn't replace the engineer.
Exactly. It
Yeah.
dramatically scales whatever the engineer is pointing it at.
Yeah.
Technical competence, the T-shape, the projects, that's just the baseline to enter the arena.
It just gives you access to the amplifier.
Right. True mastery is having the vision to point that massive computational leverage at systemic bottlenecks. Are you building architecture that solves real inefficiencies, or are you just using massive compute to generate trivial noise?
Like, just because you possess the capability to build an intricate multi-agent LLM system doesn't mean the problem requires it. Sometimes a simple regex function is still the right tool for the job.
Yes. It requires extreme engineering intentionality.
Mhm.
The AI isn't the driver, it's just a very powerful engine. You, the engineer, still have to steer.
If you point a massive engine at a trivial problem, you just get to the wrong destination significantly faster.
The most impactful practitioners combine their competence with a clear vision of what problems are actually worth solving.
So, to quickly synthesize this roadmap for you as you sit at your IDE, first, build that T-shaped profile. Pick a deep vertical and completely own its mechanisms.
Second, respect the hands-on imperative. Prioritize the friction of broken code over the sterile comfort of reading.
Third, showcase the full life cycle and an honest evaluation of limitations in your portfolio. Fourth, pace yourself with sustainable rituals, one tool a month, one paper a week.
And finally, lead with vision.
It's an incredibly solid blueprint, but there is a final concept worth dissecting before we go. We anchored this entire roadmap on the T-shaped profile, right? Broad horizontal knowledge paired with deep vertical expertise. But if AI truly is an amplifier of human capability, what happens when your AI tools become capable enough to automate the broad horizontal part of your skill set?
That is the million-dollar question. If these foundational models can write boilerplate integration code, architect basic pipelines, and automate the generalized knowledge of the entire ecosystem, does the AI itself become the horizontal bar?
Will the AI engineer of the future only need to focus purely on their deep vertical?
Will the T shape evolve into an entirely different shape, like an incredibly deep, narrow I shape?
That is a fascinating systemic shift to consider while you are debugging your next context window. Thank you for joining us for this deep dive. Get back out there to your IDE, embrace the friction, and start building your first project of the week. We'll catch you on the next one.